smiling coders, let's focus. So next thing I'm gonna focus is my agenda is to more of focus on the next thing is MongoDB internals. So MongoDB also uses the same triggered storage engine. Generally, it will also have val. So MongoDB also uses the wire triggered storage engine, which includes for writing logging val. It ensures that changes to the disk are first recorded in the general file on the disk before being applied to the actual data file. So why I'm telling you is in MongoDB also there's a val file, but actually internally the data format is going to be different. Okay, so the data format is actually different, but the replication level and they will use some kind of so, I mean there are different types of replications they use. Okay, and that is very crucial. Okay, in distributed also, in normal scenario also. Okay, so here also they'll store a data format, so that is a void trigger general entry format will happen in MongoDB. Then they use the same process. They also use a crash recovery. They also have flushing strategy. But the difference is the flushing strategy happens in MongoDB generally flushed every 100 milliseconds or like that. Okay, there's a class recovery here also. You can replay the general files also, and you have indexing and strategy. This is also the similar aspects, right? So that is the use cases what we are trying to do here as a developers. Okay, so that's the use cases in this is the use cases what we are trying to do here. So now I'm going to demonstrate one code samples, so that once you understand the code sample, then we can give you an example, guys. Okay, so let's go to my code sample. So that is for MongoDB. This is for my MongoDB I have here for. Okay, so this is for, once again, let me see. Yeah, this is the third one is I have written it. Okay, so you can see there I am using a simple package, that is Mongo client, to connect to MongoDB, which is installed, and then I will try to create a collections and the database name and then the collections. Okay, this information I have written here. Okay, then I'm, as I told you, first we will create a general entry, that is I'm storing. If anyone passes me a general entry, they'll pass some operations, and then they'll say what type of bank accounts, and they'll store some data that I'll just return in a dictionary, storing the operations and whatever the data what we have done. Okay, and here this is a creating general entry. Okay, but if you see here, so you might have to get this question is that the, see, many people ask this. I think someone was asking this question, MVCC, that is called multi-version concurrency control. That is a core mechanism that will enable everyone non-blocking read, high concurrency, and ACID compliance. So that was a good question someone was asked thing, because we do this. The main thing is for a database is this highly concurrent, non-blocking reads and ACID compliance, right? That implement that mechanism only we do. So I have not done that implementation very core of it. That's where your whole OS layer involvement happens. But I have done a simple example is, if if you give me an entry of your database, I will try to see what operations is it. Is it I mean, if it is any kind of insert or entry, I will try to store that into another data structure called MVCC store. Okay, because generally MVCC store is nothing but they will try to store a replica, I mean, to perform that. Okay, so that is one more use cases we will demonstrate here. Okay, so each transactions we see is a snapshot of data that is exited at the time that the transaction started, even after the transactions are modifying the same concurrently, because that is what see, that the main idea is MVCC is that if you are reading, it don't block write. If you are writing, it don't block reading. That's why they use this MVC in MySQL, but generally it only used in InnoDB. InnoDB only supports that in MVCC operations, but my ISM engine doesn't support. That is the difference. Okay, so that is, it works only in that InnoDB where they use the transaction IDs to manage this things, okay, internally. Uh, so that is where we use here. So so generally they do, because why they use this MVCC is that when people are trying to read and some people are doing some kind of writing, or sometimes we get committed. No? So we use in SQL generally transactions, start transactions, and we will do, before doing that we use this start transactions, right? So that's the use case for highly concurrency approaches. So here also I'm trying to store that data into another DB, another dictionary. That's it. I'm not doing anything else. Okay, for MVC snapshot. So here for crash recovery, I am doing, what I'm doing is, if MongoDB crashes, so I will try to loop the actual database and take that information and store in another DB, and then I copy into new dictionary. So that I'm just demonstrating in that example that if MongoDB crashes, it replays the general entries and recovers the state. Okay, so that's so generally in MySQL, InnoDB we supports it, but generally MongoDB, everybody will show whether it's support, means generally MongoDB doesn't support multi-version concurrency like that, but however MongoDB implements some of that concepts using document level concurrency. It is there, but it is doing, but it is with a limited scope it is having, but that feature is highly available in the MySQL thing. Okay, so that is also possible. Okay, so then coming to how MongoDB does this, because generally they do copy and write behavior. So they, whenever anyone is trying to copy and write behavior, they update, or they will do isolation of transactions, that they will use this. Okay. So coming back to recovery part is to fetch the data and then copy to another table. That is what we are doing here. So general flashing means what we are doing is, we are telling every 100 milliseconds we want to it's to flash. So what we are doing, we are actually trying to open a file and we loop the data and we write the data. We loop that actual data and write into this file. That's it. But I have not implemented any flashing strategy. But as of now, I just read the data from the dictionary and then write into this databases. Okay, and this is a very simple example that I'm demonstrating here, guys. So that should be comfortably working here, and that's where we are trying to run this. Yeah, so that's the part of it here, and you can see there is 1 second. So to get an idea, but now I'll show you the actual code base, but that would be so I will just store. Initially what will happen is, we'll have something called general entry, that is actually will store this information. Then the snapshot of MVCC, observe this thing. Actually there is a lot of transformation happens here, so keep that in your mind always. Transformation means your actual data itself is storing in different formats, right? Initially it will store in a dictionary. Okay, then next time it will store in a dictionary that has key and again value as another dictionary, and then recover state also is the same way. So that is something that's internally happening here. So that is the way we will actually do it. So this is a little bit of I mean, it's an intermediate level understanding, but we can do a little more in depth of advanced also. But yeah, we'll discuss that. Yeah, any more questions here, guys? Okay. Yeah, I'll take your lot of questions, guys. I really appreciate everyone giving inputs. Thanks for giving a lot of inputs. But yeah, I can take up your questions. But before that, any more questions you guys have, guys? Any questions?
Yes.
Hi.
So one question I have is regarding, how the change log is implemented and how the read replicas are maintained. So,
Okay. So I will give you an answer, gentlemen. So change logs and read replicas, correct? So that is how. So you are asking in MySQL or MongoDB?
uh, yeah, in general, if you can. Just, I mean, is it different? If it is very much different, then we can start with maybe a relational database like MySQL, and then
See, generally change log is bin log. Okay, that is different. I mean, it is a binary log files that will generally store it, but they use only for replication. Okay, but read replicas is that is only your read scalability, right? Reads, because you will use a different database, one database for reading only, one for writing only, for replicating the actual data and just doing that for your. It's about your mechanism, right? So how you want to implement that, correct? But in the both the cases, it is generally, if you are change, it's mainly used for replication agents. I mean, the change log, that is your change log. Okay, but if you want read replicas, is generally for your, if you want any kind of large read kind of database system, you want to only read implementation, or then you can go for that. So that's the one thing. Because see, when you, every record, every change it will do, it has to do replication to replicas, correct? So that time what will happen, actually the change data capture will happen. Okay, and that is where they'll use something called CDC, change data capture, and point in time recovery they use. So there they use that because they want to manage that information. Hello. And if you are talking about read replicas, generally that is like a secondary DB, because if you have a full MySQL server and if you want to connect to master and read and reply, so then we want to keep the data and sync with master. Na? So read only means only that one, that replica, secondary DB if you want to use, that is read replica. So in both the cases, in cases I'll tell replica, in both the cases, if I understand, in master it writes data into bin log. Okay, and generally the replica reads also, they read the bin log via, some kind of things, but they write into something called relay log also. But yeah, so there are so use cases in that way we will be doing here. Yeah, so there is it's for real time syncing generally. See, I can give you one more thing. Generally, we use Kafka for change data capture, right? So real time syncing data with Apache Kafka, right? So they all use similar behavior. Some of the use cases. Yeah. Any more questions, guys? Any more questions, guys?
Hi.
Hi.
So this MVCC is happening in memory, or it is like the multi version will be saved in the disk?
MVCC is happening when you are doing a query. There are some processes and threads running for the tables, for each tables. So when user is querying, so that the threads or processes, when you are trying to access it, they will use the locking mechanism. So in Spring Boot, they use this mechanism, right? Locking mechanisms we have when we are trying to access only, they use it. But they don't have this facility except from Spring Boot. If other databases, I'm not sure other queries, they have this locking mechanism if you want to implement, not much. Only Spring, I think, has that feature, I guess. But
So how is it different from pessimistic concurrency control?
sorry.
So the traditional locking, right? How is this MVCs is it different from that?
But this is a mechanism that's happening internally, but still you can do the control. Control is given only in one framework. One framework that I can say is that is only Spring Boot. Only it will give you that control. So they will only give you this control to. I mean, it is handled by the database layer only, but it will provide you the transactional behavior only. To manage the transactional behavior only we can do. I mean, MVCC, that isolation, you can do that transactional behavior to ensure read write as a part of transactional, you can do this, but that is the isolation level you can set, transaction isolation level
So
you set, you
so
can.
if I understand correctly,
Hmm.
so in the traditional locking system, we have this write lock. right? So if there is one person if his write lock is happening,
Hmm.
any other person who wants to do the transaction, they have to wait
Correct.
until the lock is released.
Correct.
So is it concurrently done in MVCC, or the lock is still there?
No, obviously, that write lock is one of the feature of MVCC. You can say that is preventing the other transactions, right, from reading or writing the same row table until the current transaction completes. So that is one of the feature that itself it
No,
gives.
if you're saying concurrency control, the very word concurrency, general English is like many can use it at the same time. So
Correct.
that is why a question arises actually.
No, it is supporting three features. One is concurrency, one is transaction locking mechanism, and one more feature it's supporting. All three are inbuilt on that.
Okay, yeah, thanks.
Okay. So any more questions, guys?
Hello. Hi.
Yeah.
So you were mentioning like in MongoDB, the flushing is happening every 100 millisecond or something like that. So
Yeah.
is it more frequently happening when compared to relational database like MySQL, or and if so, why is it? Is there any particular reason for that?
Okay. So that is a good question. I appreciate for that question, because in MongoDB, compared to that, it differs in the architecture and the durability, right? But if I tell you the write latency of MySQL, generally, uh, MySQL latency is generally 1 to 5 milliseconds, but MongoDB is slightly higher. Okay, so I mean that is one thing what I can say. And when you say control on the flush, right? So they generally take more MySQL little faster. So thing, but what I see is because of the flushing thing. When write comes, it goes to the val file. It's very fast. It happens. Then it will use NoDB of the buffer pool, and then it does the flushing immediately. But flushes maybe in MySQL with 1 second or something. But that is why MySQL is doing that transaction commit fast. But MongoDB is not like that. It will first write into RAM, and then it will the flush to the disk using checkpoints. So they do some checkpoints controlled by thing. Generally every 100 milliseconds by default. But so why they do this flushing is that expensive, is that because there is they have implemented a concept called I think what I remember this they use a concept called 100 milliseconds batching they do generally.
Hmm.
So for that reason, it's one is to do a because we are using a BSON format, na, so we need a flush not always immediate, but it's a group kind of flush that they're doing it. So
So
that
that would be the reason why it's being used in more write extensive
correct.
applications, right?
Correct, correct. And also, if you see the benchmarks, also MySQL will take 1 to 5 milliseconds for insert, but MongoDB will take 5 to 20 or something like that also. And one more thing is they insert as a batch, and I mean that is why it wins in the write flush latency. MySQL always wins. Okay, so to insert that speed also, they have given they have used something called disabling generalizing also. We can do that. So and then we can use the I mean optimize the batch insertion also. They have provided that also. So that is also possible. Okay, thanks for that good question. Okay,
Okay.
any more?
Thank
Yeah. Okay, I can continue the next things, guys. Thanks for all the questions. For all excited people, so I have to give you an excited information, right? So now if you see what's happening in the actual SQL is that the SQL parser is there that converts SQL into I told you abstract syntax tree. Then there's a semantic analyzer happening. It will resolve the table column. Then there is a person called executor. It will prepare the execution plan. Then InnoDB, as I told you, this is the main layer. It will pack the row store in memory page. Then there is a buffer pool that modifies and page kept in the RAM, and then you do a redo log, and then write ahead log entry created, and then redo log, sorry, and then there's a OS page catch that data is passed to the kernel, and then there'll be a virtual file system that routes to the thing, and then actual virtual file system is there, and then they create an file system logic handling IO blocks, that is ext4 or something, and then there will be block layer, and then comes to the actual disk, and then they acknowledge it. This is a general process. But if we are asking little more depth and all, the query plan happens, index usage also happens, and for index usage they use b plus tree, and I mean, so whenever this val file is basically a visual val file, that is also present. So for a replication case, it is generally, it's a trigger insert. We can see in secondary or primary, that is about your replicas, how you do. It is in MongoDB or whatever it is, okay? We are do the sharding also with routed queries. You can do that, and crash recovery in both the cases are there, okay? And that is one thing. So coming to the next replication part, so can someone tell? So I know everyone here is going to talk about replication part. So replication ensures data is copied across multiple nodes, right? So we use a master slave, and one node is master that handles writes, other is slave, it serves reads, and all the nodes can handle read and write, right? So write is generally committed in master, and then sync to replicas, right? So that's, if it is synchronous, the write is committed only after all the replicas are acknowledged in this, right? So the sharding is also same thing. We are doing horizontal partitioning, split that data set into smaller and non-overlapping. This is not happening. So before we talk about the other aspects here, um, I'm going to show more and more uh, internals. I'm not sure. I hope everybody would have access to MySQL open source code base. Some of you were asking me a lot of questions, so I can show you the open source code here. I think not this one. We will open this one, because so you can go to this is a MySQL server, and you can see this is your client and libraries, right? So hello, I hope everybody can see this open source,
Yes.
right?
Yes.
So some of you were asking me, right? So in the open source layer, so if I am taking you an open source layer, so there is, so we were talking about our internals. In our internals, we were talking about the use cases where like this. One second, let me go here. So we were talking about each layer. So in this, in the open source code, we were asking about val file code, val file, val file code. I mean, where is that val file code? You were asking that. So most of you were asking that. And second thing is, some of you were asking that is that, so I mean, next thing is we might ask about, okay, SQL parser, you leave it. Maybe many of you are not interested to know, understand, but at least we will talk about, we will have to see the file system logic happening here, and where is that is actually present. So you can see that it is present in, actually there is a folder called storage. Hello everyone, all smiling coders, I'm going in depth. There's a folder called storage. Inside the storage there is a folder called innobase, okay, and there is a folder called as log or something. I have just gone through that. One second. Inside this innobase there is, yeah, you can see there's a log. Hello, yeah. So inside this log, so this is actually, you can see this code. This is completely a C language code. Hello.
Yes.
Yeah, this is a completely a C language code. So to demonstrate it, I know I can go very much in depth, but the problem is I'm not sure how many participants here are well versed with CCPP. I'm not going to talk about that debate now, but I'm going to talk about. I can only tell you one thing is that, so the whole implementation code is written in C and C language. Okay, so you can see this is actually the, once again, I'll just show you the actual file. One is your file capacity. Someone was asking the file capacity. So you can go to this file capacity and here you can see this. Hello. So the total physical capacity is the total size on the disk generally. So they will store that ratio based on the file headers with these things. So generally it is basically a hard disk local capacity or whatever the use cases. So this is actual code base which has a function called log file capacity limits. They use this code base, and they use one more thing called log file capacity initialize. So this is a actual code base. That's a complete C language code which they have written it internally. So if you want to go, one second, let me go here. No hurry burries, we are not going to go anything. So if you want to go to the parser query tree first, there's a query tree happens. So that query tree also is there, but don't worry about that. So most of the audience here would ask you this question. It's in C, it's in C language, okay? And so the actual code that is residing in this path. So that is, I told you the path. So you can refer this MySQL server. Inside this, remember this path: storage, innobase, okay, log. Inside that log file, you always refer this file. Okay, maybe you can see this file you refer. That's could be, you can browse it. So this is a one you can refer. This person will be having redo log system. That is, you can see this is to extract this all information. So they have written all the header files here, and this is actually the code that they have demonstrated. So you can refer that also. So log files will be generally typically 4 to 32 GB and physical thing, and log buffer also based on that size. And there's a buffer flex add-on also, they will use this here. So that is a use case you can refer here. But if you want to go more in depth here, so this is a complete C code. I don't want to more. I mean, I'm comfortable, but I'm not sure all the audience should be comfortable. That's why I'm not going to go more into this. But this is actual function they call logs is create, and that's the static function that they will call, and that is the one which is actually allocating the memory here. Okay, so entire OS event and entire, here they use a lot of mutex. Okay, and then they will do all this initializations here. Okay, so for log all the information happens. So now that you leave it, that is not a problem. So I don't want everyone to go more in depth and understand on that, but okay, it's comfortable to the level we understand. Now, hello. Yeah. So now we might be getting a question, Venkatesh. So tell me, so where can I locate the, okay, so there is something that we all want, is that what we want is, we want to know the, okay, let's say, this is actually the main code that is called InnoDB code. This is a very, very important code. Okay. That is your query execution plan and then InnoDB thing. So that part we can see now. Okay. So if we talk about, okay, so that is one thing. Now we can go here. So where is the crash recovery code? And someone was asking in a MVC. So official code, in official code, MySQL, you want to see this file code, and also if you want to see the crash recovery. What is that? Crash recovery code. If you want to see this, both of them, it's possible. Okay, so recover after the flash, that code also you can see that. As I told you, na, so disk code also is there possible. So you can take the disk code also here. So I can show you the disk code also here. So there's a place that it is actually having all this information. You can see in the, one second. So there is a place called storage, base. Inside this, there is a place called, I can see there is, one second, row. You can click on that. So that is the, you can do the kind of rollback implementation, everything here. So that is the use cases we do have here, and then here we will see the actual code here. Yeah. So here you will see the chain node of list of tables in the table, and then here you will see all the actual code of the entire thing here. Okay. So the more we explore here and this repository, I'm going to take the next meetup would be more on this repository, and maybe if you're familiar with the most of the you know implementation of C++ code, we can see entire examples inside this, how it's storing, what's happening internally, are we what set of code base it's implemented here, so how that's gonna work here, that also we can do it. Yeah, you can comment here any questions related to this also. I'm not sure how many of you have gone through the MongoDB replica also. How many of you have gone through the MongoDB source code, guys? Explain. Yeah, definitely. I will just show you. The next plan is that only, because I see a lot of smiling audience are looking to understand the internals. I can demonstrate this repository because we are already creating some internal tool, some kind of thing. So I can demonstrate you because we already sourced this understanding. Okay. Official code. If you want to see this, one second. So of the official code, what we have, one second, that's a repository. I have gone through the MongoDB official repository. One second. Not this, I guess that's a native one. I think there was one more. One second. Let me. This is a one. Okay, and this is the actual one. Okay, so inside this one, this is actual code base. Okay, if anyone of you have gone through this or anything, if you want to know this inside this, yeah, this is a right moment, because inside this, the crash recovery, anything code, if you want to see that inside MongoDB, there is a folder called as DB. You can check that. I have referred that DB. So Mongo, inside this there is a document. So okay, click on source. I think I'm no, one second. Yeah, it's there. See, inside this DB, you will find something called as storage. Yeah, inside the storage you would find something called here WiredTiger. So this is actual recovery code will be there here. There is something called as here recovery will be there. You can check here. Data recovery, something we got, guys. Maybe you will find here. Yeah, you can see recovery unit and recovery status, and here you can see there is. Okay, here I'm trying to demonstrate everyone. Here you can see there is a code here. Once again, it's a complete C++ code here. Okay, so if you want to go core in depth, guys, all the smiling coders here, go with C++ here, because to understand the actual code base of this, you have to go this. There's a file called here data recovery. I don't know. Once again, just search here. I'll say data underscore. I was just seeing that. So
I can see a file called recovery underscore unit.cpp.
Sorry.
Source Mongo DB
Uh-huh.
storage and then recovery underscore unit cpp.
One second. Inside storage,
Yeah.
here you saw recovery underscore storage. Okay. Inside, correct. So you're talking about this file, here, in this path you are talking about. Okay, maybe if anyone wants to understand the storage
Yes, correct.
here, right? Okay, thanks for that. And if anyone wants to understand the storage part code, so go through this code, guys, because this is a main part. This is storage unit code. This is a main storage unit code. So they actually wrote all the code of the storage part. That's what we say in a BSON object, and whatever code base we see now. That's the actual engine part of code is here only. So they have implemented all the engine part of code here. So this is actual disk space monitor also they have written. See, that is also there here. You can even refer that how the disk storage monitoring is. That business logic is also there. So yeah. So that is I think I will just check it once, guys. I think I just somewhere lost in between, but I can definitely give you recovery unit. Recovery unit not. I think there was a file called data recovery.cpp and kvengine.cpp. I think we'll check that. Thank you. Thanks for that. Yeah. So now, I hope this is something we had an interesting journey here. So further we will have a lot of exciting journeys on the similar SQL part. So I was just want to help people to understand thing. So there were two things we can do. One more is we can make you guys run through the lot of similar examples to demonstrate. I can do that for you. And yes, so any questions if you have, you can ask me here. So this part, so any Q&A, question and answer, guys? Any Q&A? Hello? Yeah, we see a lot of smiling coders. Yeah, any Q&A, guys? Okay, so any more questions? Okay, whole file system is scripted in C file. Okay, very good question. Why are they using C code? Correct, that was a question asked by Victor. Okay, so the reason is it's the simplest reason. The simplest reason they are using is because there is InnoDB. Okay, InnoDB is actually a layer that is primarily written in C++ for two purposes. One is it's a for low level control, because we will especially work with IO operation, memory allocation, because C language is good for that, because we are database is all about what? It is all about control over memory, CPU, thread, right? Generally. Second thing, our intention is the InnoDBs, buffer full, val are heavily optimized with pointers, threads, locks. That is bestly done in C language. For that reason only they have used in thing. Second most important reason, maybe you asked a good question, because C language is portable to any of the operating system, whether it is anywhere, any of the operating system. That's why if you see all the databases, they will primarily implement it C and C++ only, because it is portable and it is possible to port it across various operating systems. Yeah, any more questions? Any more questions? Okay, because Java will be JVM, Java needs JVM, that will become too heavy. Python also too slow. And I think now they're slowly working with Rust based thing, but still for all the databases they will use that. Yeah, there are some databases coming on Go language. Yes, there are some databases coming on Go language, but there are some databases also initiated on Rust also now. But yes, so that because Go is also primarily inherits the C language feature, right? That's the reason. Any more questions, guys?
Yeah, Venkatesh, I had a question.
Yeah.
So you mentioned that new database are also being written in Rust. So what specific advantages do you think that Rust offers as compared to C or C++? Because both are closer to the hardware's kernels and both offer memory safety as well. So
Uh, now there are some databases written in Rust, Rust and Go language. If you ask me why it is, what all are written, it means in the questions is that I can give you one example. There is one database that's called TickV something. I think I remember that they have written it in Rust actually. Lot of databases are coming in Rust. Okay, and some databases are written in Go is CockroachDB. Okay, and InfluxDB also has been written in Go. So you might be getting question. It's correct. TIV, correct. So maybe you will again ask this question, why there means, don't worry, again to interface with low level kernel, they'll use C language only here. But still they have written the top layer in the Go. Okay. So their layer of log file that all same, but they still interface with in terms of OS interfaces, they'll do this. So it's still they'll do implementation with that. But yeah, you can say that they have done implementation with, because they have that because they want to go with cloud native. And so because Go is good now, it's good in concurrency, so that's the reason they choose it. Rust is also good for that, but memory safety is also there. For developer that doesn't matter, but why they used Rust in systems level is that because they will have good, right, they'll have control over the entire whatever the implementations they are doing, right, they'll, because of the memory management thing, they can be able to troubleshoot all the runtime crashes or any kind of things. Tracing, it's at pretty good at the entry level. That's why they will use that Rust or Go. I mean, that is one of the core reasons people want to use both of them, because they see that is a future. That's the reason. Yeah. Any more questions? Any more questions, guys?
So how can you hear me?
Yes, I can hear. Please.
Hello, can you hear me?
Yeah, I can hear you. Please go ahead. Please go ahead.
Yeah. So how relevant it is to know about the language of the database written, does it matter in architecting the database for the enterprise?
Not for enterprise. I'm just telling. See, I am actually having enterprise level experience, but what it actually matters for some architectures is that some of the organizations want to have their own databases. Okay, I will tell you an example. There are some banks that they want to have own databases, and when they do want to have it, so they see their core problem of the database. It means in terms of, when we say a database, we are implementing it. So what is that unique thing you want to bring in that database? Whether you want to bring in the speed, or whether you want to bring in the transaction, or whether you want to bring in what is the thing, right? So based on that, so companies are choosing it. So every database, uh, new innovations of databases are coming for industry specific. I'm not talking about general thing. I'm talking about industry specific. So industry specific are they coming? See now, for trading, for trading or for banking, some of the thing, we are still not using single database. We are using various databases. So
Correct. Yeah.
so to overcome that problem, industry based databases are coming up.
So this is open source or OEM databases?
These all are open source now. So now what we are trying to see, industry based is coming up. And when I say that, currently for industries are core banking systems and all, right? So I mean, as we know, Oracle is only one database. We know that IBM's DB2 like that, right? Now,
Yeah, so because the enterprise today will select any database like banking or trading, they first thing they're looking for is that who will support the database.
correct.
They want a surety, and then that is why they do not jump into open source very easily. So somebody assures that okay, if they pick up any open source database, somebody should, because their employees will not take that accountability of if something goes wrong, who will support that database?
Correct.
So that was my another question.
Correct. So your question was, you want a database that should be complex compliance supporting and high fraud risk. I mean, whatever you want in these two
Yeah.
aspects. Correct. So in these two aspects, as you see, the current databases are the richer one, but currently there are new innovations happening. As I told you, there are various new databases which are coming with compliances based and industry based are coming up. So industry based new innovation databases that are upcoming. I can give one example, best, which is faster. Okay, so that is one of the, you can see that is, I'm not talking about thing. There is one database called SuralDB. SUR, I think I can pronounce that properly.
Yeah, no, yeah, understood. Yeah, yeah. SuralDB, yeah, okay.
Yes. So that is one of the database that works. It is faster than any MongoDB or any of the database. That is
Okay.
built in Rust actually. And for there is one more database that's coming on, something called Materialize also, real-time
Okay.
analytics. So see, now I say I'll give an example for real-time analytics. Still we are still relying on only on pandas. Now, pandas is internally a database only, but still again,
Okay.
when you're sending data, then again we are doing ETL. For that also now there is some innovations happening. There is one database that is coming called Rising Wave. Okay, so
Okay.
there are a lot of such transformations are happening.
So, which means I'm just coming from the
Hmm.
other technical background that a person who knows the, let's say, 3 or 4 databases in the past, will he be able to pick it up and understand, or we can and uh, design for the new upcoming databases which are coming up now, or will it be totally different?
No, it will be similar, but the see normal audience will know only the syntax level, but the core guys, who's architects guys, they have to know the difference, right?
Exactly. Yeah.
They have to
Correct.
know the
Correct.
difference. So what's happening? So I told you, Sural DB, that fellow is only for SaaS and dashboards. They will use only specifically for that. And
Oh, okay.
when I say materialized thing, that fellow they'll use for only fintech. So as I told, now industry-based databases are coming up, not like
For
generic.
a specific use cases, you mean to
Yes,
say,
yes, that is
they
what
are
is
they are
coming up.
they are
They're
creating,
coming up.
which means then I will have, let's say, 10 different use cases in my organization,
Yeah.
and I know that for 10 different use cases there are, 10 different types of databases available to
Correct.
optimally use that use case. So I will have then 10 different databases in the organization for
Correct.
specific use cases. Correct.
Yes. So that is what its future is in the DBs is all about.
Yeah. Yeah. Okay. Okay.
Yeah.
Right. Fine. Fine. Thanks a lot. Yeah.
Yeah, thank you. And any other question? Others? Abhishek. Yeah, we have Aditya. We have Ajit, Akshay, Anand, Srikumar. I think we have Divakar, Gautam. Yeah, we have G Zin. Yeah, JGM, Jiv. I think Karthik. Any questions? Parthiban, Rajesh, Rupesh. I think we have Sai Pujita. I think Sandeep. Any questions? Sanjay. Yeah, thanks for staying, guys. So Shailesh, Shiva. Yeah, any questions? Varun, Vignesh. Any questions?
Hello.
Yeah, yeah, please.
You said you'll be talking about InnoDB, right? I don't have yeah this any JSON base.
Yeah, yeah. Any questions?
Yeah,
Yeah.
Venkatesh, I had a question.
Yeah, yeah, please. I think any one of you can do that.
Yeah, yeah, someone else can go ahead, please.
Yeah, yeah, yeah. Yeah, Srikanth.
Okay, so I'll ask my question now.
Yeah, yeah, please.
So when we say we are creating new databases or companies want to have their own databases, are we talking about completely new databases that are built from scratch, or as in taking some one open source database and finding it to their catering needs? So what are the spectrum that we are actually discussing?
So the spectrum we are discussing is that now industry is coming with lot of industry specific database. Means now we are trying to solve industry specific problem. For that industry, this database is it's gonna meet at least 80-70% of its requirement. To fulfill that, they are trying to solve that industry problem. So they are doing some innovation on that industry problem itself, instead of catering to all the, just giving the databases common to all the problems or thing. They're customizing very specific to the tech industry. So that can be fintech or can be banking. So that's the kind of innovation they are bringing up.
Understood.
Yeah. Any more questions, guys? So yeah, so Victor, I see that, yeah. So I did this Python to demo it, so to understand it, but actual code base to demo it, the problem is we have the various complete C language code, and it's a complete C and C language code. So that's why I just did the entire logging with the Python level. So if the audience has any more questions, we can take it up. If not, thank you for everyone for joining this. So we will get you this. This recording will be shared in the our YouTube CoderRange community. So you can have a look at our YouTube thing. You can go and refer our video there, and we'll share you the code samples and everything over there. Okay. So you can basically be part of our community that is in YouTube, that is CoderRange. So you can be part of it and get all other content shared over this. Yeah. If you have any queries also, you can put that query in our meetup, as well as you can also share how this session has shaped you to better understand database. Also share your reviews and inputs or our community page. Okay. Thank you everyone for making your time this Sunday. Looking forward to meet you on the next meetup, guys. Thank you very much. Thanks to all. Keep smiling and have a great next upcoming week. Thank you, everyone.